In this video, we're going to talk about the graphs of inverse functions. Remember that for any function f, its inverse function, f inverse, is a function that reverses the operations of f. A good way to remember this is by using the following diagram. If we plug in any input into the f function, so let's say we plug in the input a, f will perform some operations on that input and give us some output. Let's call that output b. Now, if we take that output from the f function and we plug it into the inverse function, f inverse will undo the operations of f and give us back the original input that we started with, which is a. So looking at our picture here, we can say the following, that if f of a is equal to b, meaning if I input a into the f function and we get the output b, then f inverse of b is equal to a, meaning when I input b into my inverse function, we're going to get the output a. The statement here can tell us something about the graph of our function and our inverse function. If f of a equals b would mean that if I have the point a comma b on the graph of the function f, then f inverse of b equals a would mean that I have the point b comma a on the graph of f inverse. Using this fact, we can draw the graph of f inverse using the graph of f. All we have to do is take each point on the graph of f, flip the x and y coordinates to get the corresponding point on the graph of f inverse. Let's take a look at an example. In our example here, we're given the graph of f in blue, and we want to use that to help us draw the graph of f inverse. To draw the graph of f inverse, all we have to do is take the points that are in the graph of f and flip the x and y coordinates. So for example, on the graph of f, we have the point -5, -2. Flipping the x and the y coordinates, this tells me that the graph of f inverse would have the point -2, -5. Next, we have the point 0, -1 on the graph of f. So on the graph of f inverse, we would have the point -1, 0. Next, the graph of f has the point 1, 1. If we flip the x and the y coordinates here, the point would still be 1, 1. So this point is on both the graph of f and f inverse. Next, we have the point 2, 4 on the graph of f. So on the graph of f inverse, we would have the point 4, 2. Lastly, f has the point 4, 5, which means that f inverse, if we flip the x and the y coordinates, would have the point 5, 4. Now all we have to do is connect our points with straight lines, and that gives us the graph of f inverse. Now you might notice that the graphs of f and f inverse kind of look like mirror images of each other. But we're not mirroring across the x-axis or the y-axis. Instead, we're mirroring across the diagonal line y equals x. We can use this idea to help us quickly draw the graphs of f inverse. If we take the graph of f and we mirror it across the diagonal line y equals x, we would end up with the graph of f inverse. Let's use this technique to help us draw the graphs of more inverse functions. Once again, in these examples, we want to use the graph of f to help us draw the graph of f inverse. In example B, we have the function f of x equals square root of x. Let's start by drawing the graph of f. We've learned previously that the graph of the square root function has the following shape. So if we want to draw the graph of the inverse function, all we have to do is mirror it across the diagonal line y equals x. So let me draw the line y equals x as a dotted line here. Now, if I want to draw the mirror image of f, I want to imagine taking any point here and flipping it across this diagonal line y equals x. If I had a point up here, and I flip it across the diagonal line y equals x, I would end up with a point over here. Any point that's on the diagonal line would remain where it is. So doing this with every single point, we would get a mirror image that looks something like this. This is the graph of f inverse. Now let's look at example C. We have the function f of x equals x cubed. Again, let's start by drawing the graph of f. We've learned previously that the x cubed function has a shape that looks something like this. So if we want to draw the graph of f inverse, we will need to flip this graph across the diagonal line y equals x. So let's draw y equals x as a dotted line. And again, to take the mirror image, I want to imagine taking any point that's on my graph of f and flipping it across this diagonal line. Take any point here, flip it across the diagonal line, we would get a point on f inverse. So if we do this for every single point, we would end up with a picture that looks like this. So what we have here is the graph of f inverse. And if you remember from a previous video, this purple graph looks like the graph of the cube root of x. And indeed, x cubed and cube root of x are inverse functions of each other. Let's now look at example D. We have the function f of x equals 1 over x. Remember that the graph of the 1 over x function, or the reciprocal function, looks something like this. To draw its inverse function, we want to take its mirror image across the diagonal line y equals x. So let's draw in that diagonal line. Now, if we look at our function f, we see that our graph is symmetrical about that diagonal line. Any point that we have on one side of the diagonal line, we see its mirror image on the other side. Take a point over here, we see its mirror image on the other side of the diagonal line. So if we take the graph of f and we take its mirror image across the line y equals x, we would end up with the same picture. So the graph of f inverse would look identical to the graph of f. Since the graphs of f and f inverse are the same, it means that they're the same function. So this tells me that the 1 over x function is its own inverse. So in this video, we learned how to draw the graphs of inverse functions. All we have to do is take the graph of the original function and flip the x and y coordinates of its points. Or more easily, we can just take the mirror image of the graph across the diagonal line y equals x.